I want to show you something that we all know about regression, but sometimes we underestimate it. I want to just draw a very simple regression situation here for us. Okay. So let's say that you have your y-axis there, and then you have your x-axis here. Okay, and this is a sort of regression that you want to actually deal with. Okay. In this regression, you have some observations. Okay, so observations like that, you have all of them shown. Okay, all of these observations like that. And then sometimes you have a regression line. Okay, so you have a regression line and you throw that regression line throughout it. So let's say it's a negatively related kind of regression line. And we did indicate that there are gaps. There are gaps between the observed value and then the regression line, the fitted line. Okay, there are gaps. There are gaps between each one of them. There are gaps between. So if you look at this one, there's a gap between this one here, okay, and then the very regression. There's a gap between this one here, okay, and then the regression. There's a gap between this, and these gaps, we have names for them called the residuals. Okay, so we have the residuals. We have the residuals. If it is below, it's negative. If it is above, it's positive. If it's below, it's negative. If it's above, it's positive. You remember this? Okay, and whilst you have this, and of course you have your, in this case, let's say quantity demanded here, and you have your price there, something like that. The goal is to, one of the assumptions of regression is that the expected value of the errors should be what? Should be zero. That's one of the assumptions. The expected value of the errors should be zero. Now we want to verify this with our data. We want to verify this with our data set. Okay, so let's go to the R. Before we do that, you plug in these packages. Okay, these packages are quite many, so you can later zoom in and then get a clear indication of what I mean by a plugin. Okay. So I load these packages, and then, of course, after loading the package, we are going to create the fitted line. Okay, we're going to create the fitted line, the residuals, and the fitted line. Of course, you have to remember that the fitted is the estimated, the residual is the estimated, the fitted minus the actual. I want to repeat that. Okay, let me just use some small mathematics here, which will probably explain it better. So we have something like y equals to beta naught plus beta 1 x plus the error term, okay? So that's it. We have something like that. And we have estimated. So now that we've estimated, we now have y cap, okay? Because y has been estimated, okay? So y has been estimated. So the estimated line becomes beta naught cap, okay, plus beta 1 cap, okay, x cap. The error is zero. The error is zero. Now the error, which is the residuals, okay, the residuals cap, okay, the estimated residual is therefore going to be this y on the left-hand side minus the whole of this. That's how it's going to be. So the estimated residual is going to be the y cap, the estimated, minus, let's call all of these the actuals. Okay, or better still, the actuals minus the estimated. Okay, so if you look at this, that yi, the yi minus the y cap will give you the difference, will give you the u. Because here there is zero there. And because there's zero, anything at the top, equation 1 minus equation 2, okay, that is going to give you the the actual error, the residual that you need. So this one, let me just delete that and just rewrite it for you. So what it means is that the residuals, which is the U, is going to be the Y I minus the Y cap. Okay, so that's what it's going to be. So what we want to do is to determine, and we expect the average, this is expected value. Okay, we expect that this whole thing becomes what? 0. If it is not 0, it means that there are some errors in there. Okay, so of course, these errors, you have to deal with them or you don't have to deal with it. And this is important because I want you to understand that the entire regression more or less focuses on these errors. Because if the errors are not 0, we are now going to deal with other complications of the errors. The heteroscedasticity, the autocorrelation, because the expected value of the error is not 0 and all of that. So it's very important sometimes to determine whether these errors are 0. So let's go do that. Okay. So the first command where we mutate, in our case, the kill hat. So we create the fitted values. Okay. So we do that. We create the fitted values, which is what I've done. And if you go up there, you can find the created fitted values in the observations. Okay, let me just, okay. So up here, you can see that I've created what? Kill hat, which is a fitted values. Remember, the actual kill was 160. Okay, that was there, 160. Okay, but estimated kill, which is a kill hat, is 161.7 approximately. Okay, 161.7. You see, it is already giving us the U hat in there, but let's move on. Let's move on. So how do we now determine the next particular? So now that we have the kill hat, we can now go ahead and then find our U hat. Okay, we can generate to find our U hat, just the first part, okay, of that. And then we can now use this last command here, which is kill hat. So I want the entire data set for the average for the kill, which is the actual, the kill hat, which is the fitted, the predicted, and then the U hat. So Stargazer is going to help us to be able to put everything into a very nice. So what it means is that kill is actually kill hat, okay, plus U hat. And so the mean of the U hat, we're expecting it to be 0. And we can determine that by running this regression. So look at the solution. Look at the beautiful solution here. So you have the statistics of each one. For the first 6 observations, that's all we want. Okay. So if you look at it, you will notice that the mean is 178 for the kill. And then for the kill hat, it is 177.3. And then the difference, the U hat, is what? 1.04. Okay, 1.04. So that helps us to know our entire regression process that we have. Now, let me just delete this and see what is going to happen now. Let me just delete this slightly. Okay, so it gives us some slight errors there. Let me just put in 40 for the entire observations. Okay. But the key point is that you can see that the U hat, the errors is not 0. Okay. You can see that the average of the errors is not 0. It is almost 0, but it's not 0, it's 1.024. So that means that there is a modicum of errors that are eating up in this. Now, this helps you to always be able to determine, whether the errors, the expected value of the errors is truly equal to 0 or not. And Stargazer is a very nice way to just put all of this into a beautiful table in that regard. So that's just for you, for those who might be interested.